Hello, my name is Arjan and I will talk in the next 20 minutes about closing the gap between permissioned public blockchain. I have a background in IT and corporate services and currently work as an independent software and blockchain developer. I'm also æternity lead ambassador for Lithuania and Bulgaria, as well as a certified developer for Tesla's Hyperledger Fabric and Hyperledger Sawtooth. Now, unlike many other people, I didn't make my entry into blockchain via crypto-based public blockchain. My first experiences with blockchain was actually enterprise-grade permission blockchain. Yet I joined the æternity community, and not without reason. As a developer, I very much care about the value of a technology, and therefore I work with different technologies, and that includes both public and permission blockchain. Because every use case is different, and every use case has its own unique solution. In this presentation, I will explain why permission blockchain exists, because I think it is important to close the gap between these two worlds within blockchain. Most blockchain use cases, at least the ones I work with, aren't so black and white that they can simply be thrown on either a public or permission blockchain. And that is why it's important for these worlds to grow much closer to each other. Now, enterprise-grade blockchain differs from public blockchain because it adds elements of permissioning, and it has a different focus than most public blockchain systems. Many enterprise blockchain applications rely upon real-world trust relationships, and the goal is to set up participants in an ecosystem which has the needed insurance that it's flexible enough to bring more participants together and in the network in the future. Most enterprise blockchain systems are also not crypto-based, but leave an eventual token implementation up to the developers, as well as the decision to have a token at all. Now, with public blockchain, everyone is kind of anonymous, as long as you don't reveal your wallet address or register something like arjanvaneersel.chain at the æternity naming system, then nobody will know to whom that address actually belongs. With permission blockchain, this is very different, especially consortium style blockchains. There, we know exactly who you are. We know exactly what you can do, what you may do, and what you are in fact doing. This is not a design flaw. This is done deliberately because the use case requires so. It was in fact never meant to be a public system, but instead a tool for different parties to work more efficiently by sharing an immutable infrastructure. One of the criticisms against permission blockchain is often that people say, but it's not really decentralized. And I agree to some extent. If you look at things from a technical perspective, then yes, we might argue and have a debate how centralized or decentralized permission blockchain in fact is. However, the truth is that most use cases with enterprise blockchain are mostly about data decentralization. This is so much more important than technical decentralization, especially in those networks where we already know anyway who everybody is. But what really matters here, as I said, is that there's absolutely no centralization from a data perspective. Some use cases also require a higher degree of security, for example, role-based access control. If you come from public, fully transparent blockchain, then you might not like the ID, but there's a reason. It even makes sense in my opinion. Because when we are dealing with business data, and that's what we're talking about, then an auditor should definitely have a higher degree of access than your competitor. The community of participants uses the system, just as with public blockchain, to record promises, trades, transactions, whatever things they don't want to disappear. However, under different circumstances and conditions. Now, a real use case I'm working on is a system for regulatory compliance. Here we are talking about regulators and regulated companies using the blockchain to deal with regulatory reporting requirements. Here we are talking about a very conservative world. A world which has absolutely no affection towards blockchain. So getting people enthusiastic for blockchain is already a challenge on its own. Some of the criticisms which I heard when discussing the different technology options, not willing to accept cryptocurrency-based solutions. Unfortunately, this is the way things are at the moment. Some people will simply reject a perhaps superior solution just because they don't like crypto. And although this might sound pessimistic, it is in fact normal if we consider the current state of blockchain. We are all early adapters. Blockchain is still relatively young from an adoption perspective. And it's going to take a while for crypto to become mainstream. Another thing, and I think we can all relate. We meet a person and then the person asks, what do you do for a living? So I say, I'm a software and blockchain developer. And then you see them think. And they think, and then comes the question, what is blockchain? Then imagine trying to get people together on the same network. They already don't trust each other at all. For example, because they work for competing companies. And then not having a clue what the technology is about and trying to explain the benefits of sharing their infrastructure. And when you accomplish that they accept the idea of blockchain and having this shared infrastructure and what the benefits are, then still what was the number one thing for them to accept it is that their vital business data is protected and only shared on a need-to-know base. So that means in this use case between regulated companies and the regulator. Now, why did they reject public blockchain solutions? Well, the regulators did not like the idea of cryptocurrencies at all. They were not even willing to consider. The regulators' companies were, not without reason, very protective regarding their business data. And this is data, if in the wrong hands, which could seriously damage their business. So of course they are careful, of course they are skeptical. And therefore these companies did not like the idea of some random nodes having their so valuable data. And they liked the idea of their competitors' nodes having this data even less. And even if it would be in an encrypted form, it was simply a no-go. So the technology stack that was chosen for this particular project was Hyperledger Fabric. And why? Well, Fabric allows to create a consortium-style blockchain. And that is what we are talking about. This is not a blockchain that simply everyone can join. It's in fact a closed ecosystem of known participants sharing a single or limited set of goals through a common infrastructure. And Fabric has this very powerful feature called channels. I won't go very much into the details of fabric channels, that's not the purpose of this talk. So I will say that these channels are somewhere between state channels and subchains. And in this use case, regulated companies had an individual channel with their regulators. And in Fabric, channels have their own ledger. And this way, regulators would see the transactions in their own jurisdiction, and regulated companies could be sure that nobody else than the regulator had access to the data which concerns them. So, on the channel, there would be the regulator and the participant. Competing participants, competing companies would never be on the same channel. Neither would regulators from different jurisdictions ever be on the same channel. So this way, the regulators only had access to the data which concerned their jurisdiction, and competitors would also never see each other's data. So, why doesn't everybody use permission blockchain then? Well, the truth is that the use case which I just explained is kind of an extreme situation. And this is really a very typical consortium style blockchain. Many enterprise grade blockchain use cases aren't even suitable for a consortium style blockchain because they have elements of both private and public data. So using such a closed system would definitely be a wrong choice. And that is why, in my opinion, it is very important for public blockchain systems to close the gap with permission blockchain. As I said, most use cases are a mixture of private and public data. They require a philosophy of private what can be private, but public what should be public. And that means that they in fact go semi-public, as I like to call it. And that means that the network becomes a concern. I think we can all remember certain Bitcoin forks. They got a lot of attention even. And these are forks of which everybody would reasonably think that it would be easy enough for them to get enough of nodes in the network. Yet they still became the victim of a 51% attack. So if this is already a concern with famous forks of famous blockchain systems, then imagine how difficult this gets when we're talking about something which is just semi-public, and especially if there's not even a rewarding model for network participants. Yet getting the network right is vital to guarantee stability and data reliability. So now that you have an idea about why organizations might pick private blockchain over public blockchain, as well as a rough idea of private and permissioned blockchain, let's talk about æternity, and let's realize that also æternity offers many facilities which could help to solve these typically enterprise grade blockchain problems. Now, the most obvious one is that in æternity the network is not a concern. I mean, æternity already has a blazingly fast and reliable network. So, here's a very clear advantage. State channels, yeah, they might not have their own ledger, but they do offer a form of privacy which will do just fine for many enterprise use cases. What happens on the channel stays on the channel. What needs to be public can be published as public to the blockchain whenever that is required. And also, believe me when I say that setting up a permissioned blockchain network is anything but easy. So why not consider launching a private æternity network when all we need is in fact a slightly more private blockchain. dApps could, depending on the use case, run on either the public or private network and then easily interact with the other network. And then add to that the other conveniences like Oracle integration, the naming system, and I think it becomes quite clear why æternity also has a lot of potential to deal with those typical enterprise grade use cases. I don't have the time in this presentation to show a demo or even a technical explanation about state channels or launching a private æternity network. But I do recommend the videos which you see here. They are definitely worth watching if you're more interested in state channels. This was it for me. I hope that this presentation was interesting for you and that you got a better idea about permission blockchains and why they exist, as well as having ideas to discuss this topic further and to have some exchange of ideas how we could use æternity to solve these issues, and perhaps even for a future development of æternity to at least think about whether it makes sense to implement some elements of permission blockchain into the æternity ecosystem to also serve these use cases in an even better way than is already possible at this moment with æternity. I thank you for your attention, and if you have questions, then I'm here online to answer your questions, and I'm happy to do so. Have a nice evening.